Okay, so I just turned the camera on and off. Let's think about the 10 and 9 case.
Well, Penelope will win most of the time if she flips 9 heads.
Okay.
Because she'll win every time, but the time Peter gets all heads.
Okay.
Well, that means, well, how many coins will there be?
Yeah, so calculating out for this one's going to be tough, but let's do this calculation. We'll do this part of the calculation, then we'll see if we can see what's going on more without calculation. If she has 9 coins, what's the probability that she flips 9 heads?
Well, it's going to be 1 over 2 to the 9th.
Which is, I believe it's 512.
Okay. So 1 out of 512 times she's going to flip 9 heads. And she's very likely to win in that scenario. But it's a pretty unlikely scenario.
Yeah.
So how many times does she win?
Well,
she wins this is out of 1,024. So she wins 1,023 out of 1,024.
Interesting.
So she's extremely likely to win.
Yeah.
But it's highly unlikely that she'll ever get this situation. But it's more likely that she'll win from the situation. Well, it's more likely that she'll get the situation. Well, that.
Yeah, it's tricky, right?
It's more likely that she'll win from the situation than get the situation.
Well, that's interesting. If she gets that 1 out of 512 shot, she'll almost always win. She'd have to be incredibly unlucky to lose. But it shows you if we try to do this calculation, we're going to have one denominator here of 1 over 512, and the other denominator on this side is 1 over 1024. So we have a very large denominator when we multiply. So actually trying to calculate all the cases is going to be tricky. Let's see if we can think about some other way to think about this.
Well, at the end, if she gets all tails at the end, she could win this once. She could win once, and that would pair with the one up here to form a pair.
Oh, and what happens in that pair?
Then that becomes, I think it's it was 1,023 out of 1,024, so it would become 1,024 of 1,024.
Oh, hey, high five for that. That's a very interesting argument, and you can see it here with our 3 and 2 case. There's some symmetry happening here with the all heads and all tails cases for Peter. And they seem to add up to 8/32, which is 1/4, which is the probability that it was over here, right? So that's a very good observation. That's a very good mathematical argument with symmetry. And look what happens on the other 2 sets of cases in the 3 and 2. What do they add up to?
They add up to 4/32 and the 4/32.
Which is?
That's 8/32, and that's 1/4.
It's 1/4. So we seem to be able to split the things in half, and they add up to half the things over here, which is 1/2. That's interesting. That's a very good observation. And it might be that we can continue that calculation all the way through and see the half. Is there any other way? Can you see?
Well, kind of. They have some. You could try to rearrange cases.
Because these 3 cases, you can all rearrange them to form the same case.
Okay.
Like you can do this.
All right.
And all those cases match up to like this case. And these 3 cases match up to this case. So you do have some grouping here.
Yeah, maybe there's another way you can group and understand. Yeah. Do you see there's some interesting things in the grouping? It goes 1, 3, 3, 1. This one goes 1, 2, 1. You see that?
Yeah, because this is the same as that.
Yeah.
That's Pascal's triangle.
And that's also the powers of 11.
Yeah, you're right.
Pascal's triangle, What would the...
So that shows you that maybe the calculation's not as hard as I was pretending it was, because maybe Pascal's triangle will help us simplify the calculation.
This is the third scenario. The first one was the 0 and 1, and the 1 and 2.
Right.
So this is the third row. It's the third situation in the third row of Pascal's triangle.
So maybe it's going to be the 10th situation in the 10th row of Pascal's triangle.
What is the 10th row?
We could write out Pascal's triangle and try to find it.
Yeah. Yeah, we could. Let's see, I think we're going to run into some pretty big numbers pretty fast if we try to write out Pascal's triangle. But it's not a bad idea. I mean, that would at least show you how to get through the calculation. So we get 1, 1, 1.
1, 2, 1.
1, 2, 1.
1, 3, 3, 1.
1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1. So that's the fifth row.
Yeah.
And then 1, 6, 15, 20, 15, 6, 1. Maybe we should write that at the top.
Yeah.
So that's the sixth row.
All right, I'll write it at the top. 1, 6, 15, 20, 15, 6, 1.
1, 6, 15, 6, 1. Well,
and 1, 7, 21, 35, 35, 21, 7, 1. 1, 8, 28, 21, 35, that's 56, 70, 56, 28, 7, 8, 1. 1, 9, then 36, then let's see.
84.
Yep, 84. Then 126, 84. Wait, 126 again. Then 84, 36, 9, 1.
Hey, we're going to get it.
Yeah.
Okay.
Now
1, 10, then 45, then 80. Is that 84?
Yeah.
Okay. So that's 120. Then 210.
And then 136, 126.
It's 252. Then 120. Wait, 210. 210.
And then 120.
120. 45. 10. 1.
Okay. So we would have a lot of calculating to do.
Yeah.
So it seems like you guys want to calculate. Okay, but that's fine. I want to cut it off here because I think the calculation will be cumbersome
and huge.
And huge. But maybe there's a good way. I like your symmetry way of thinking about it. That helps simplify things down a little bit. And I like I like working this out and then going through the calculation. But someday we'll have to come back to this problem and see if there's a way
to do it easier.
To do this problem just in your head.
Because was that on a math test?
Well, this is a pretty famous problem, so it's neat to try to think about. But I think you guys did a great job with this. And it has a pretty surprising result, right? Although we didn't go through the calculation, it looks like this is a fair game. 50-50 chance of winning. All right, good work this morning, guys.